Okay, so let's take a quick look at the agenda we shall be covering here, from definition of hygiene to Cerafusion technology all the way down to summary. So definition of hygiene. Hygiene as defined is a series of practices performed to preserve health. According to WHO, hygiene refers to conditions and practices that help to maintain health and prevent the spread of disease. With this definition, we use technology to innovate hygiene through Cerafusion sterilization technology. What is Cerafusion technology and the science behind it? Cerafusion technology is an air-surface sterilization technology, comprises of few patents that controls the production of active oxygen, always on 24/7. Active oxygen is a combination of ozone and negatively charged ions. The technology are made up of three main components: the sterilization control system, active oxygen electrode module, distributed control system. All these three components are granted patents as of today. The sterilization control system is designed to control the production of active oxygen digitally according to the needs of the industry application. It has defined method of controlling the generation of active oxygen by using a high voltage generator to generate AC high voltage of a predetermined voltage amplitude and pulsing mode to control the proportion of O3 and O1 output. The second component, the active oxygen electrode module, defines the method of designing the electrode to generate and limit the production of active oxygen physically. Each electrode module is carefully designed for specific application. Depending on the electrode module, it could generate both O3 and O- in different proportion, or either O3 and O- separately. It is designed as a cartridge to ease the servicing and maintenance of the Cerafusion module. The third component is the distributed control system. It's a method of controlling the delivery of active oxygen into large indoor spaces or multiple rooms at one time. Special custom-made design nozzle is used to control the delivery of active oxygen in specific location. It has a 24-hour control system and easily integrate to ozone sensors to monitor the ozone concentration at ambient levels in different locations. If the ozone level is above the predefined level, the system will switch off and will turn on again when it's below the predefined level. Do you know that there is a major difference between a clean air and low-level ambient air? In a clean air or filtered air or a purified air delivered into a room do not have antimicrobial property, whereas the low-level ozone ambient air is in an indoor environment has the antimicrobial property. This makes it effective in sterilizing pathogens in the indoor environment. This is what Cerafusion technology delivers to perform sterilization process. Let's move on from Cerafusion technology to understanding ozone. There is a need to understand what ozone is, as it is often misunderstood, especially when someone tries to Google ozone without going into the details. What is ozone? Ozone is a gas composed of 3 atoms oxygen, nothing more, nothing less. Ozone occurs naturally, as we know, in the upper atmosphere to protect human beings from UV rays. The EPA, unfortunately, has confused the public by defining smog as ground-level ozone or ozone pollution. What I'm sharing here and the next few slides are sources from the EPA website itself. How can ozone be good and bad? According to EPA, ozone occurs in 2 layers of the atmosphere. The layer closest to the Earth's surface is the troposphere. Here, the ground level of bad ozone is an air pollutant that is harmful to breathe, and it damages crops, trees, and other vegetation. It is a main ingredient of urban smog. This picture is taken from the EPA website, specifically addressing ground level ozone. The control level of ozone, or ozone as stated here, is created chemically by chemical reaction between NOx and VOC in the presence of heat and sunlight. The ozone is not directly emitted into the air. This ozone is referred as bad ozone. This is not equal to ozone as O3. Even WHO makes it clear that the bad ozone is not the same as O3. The bad ozone or ground level ozone comes from sources such as emission from industrial facilities, electric utilities, motor vehicles, gasolines, vapors, and solvent. The ground level ozone consists of some of these toxic chemicals such as nitrogen dioxide, sulfur dioxide, and carbon monoxide. EPA's recommendation on ozone limit is based on this study, estimating mortality risk reduction and economic benefits from controlling ozone air pollution. Do note that the definition of ozone in the summary page of this study. In the footnote, you will find the definition of ozone, where it says ozone in the lower atmosphere is formed by a complex series of photochemical reactions in the presence of sunlight involving nitrogen oxide and volatile organic compounds. Ozone is used here to refer to the broad array of photochemical oxidants in ambient air, of which ozone is the primary component. Another common question asked by many people when they Google ozone or ozone generators, they will find this from the EPA website about ozone generators that are sold as air cleaners are harmful. Let us try to understand what it means. Many research studies from the past year claim that ozone generation use are harmful to humans even at low ozone concentration. But most often, we do not question what is the low ozone concentration. If you were to go into the details of the studies, you will find that the low ozone concentration used ranges from 0.2 to 0.8 ppm. This range is above the international guidelines. The international standards on ozone from a few international agencies in general sets the limit of ozone at 0.1 ppm over 8 hours based on time-weighted average. The Cerafusion technology is created and calibrated to emit ozone between 0.05 and 0.1 concentration at ambient level as desired, depending on various applications. Cerafusion technology is also tested and certified against CN, the CE EN 60335-2-65. One of the test components in the certification is on ozone concentration level, as you can see in item 32.2. So what is the difference between ozone generator and Cerafusion technology? While both can deactivate pathogens, ozone generator is not recommended to use in the presence of humans. They are not recommended to switch on the 24/7 in an indoor environment, and they do not generally comply to international standards, whereas Cerafusion technology is meant to operate 24/7, safe with human presence, and complies to international health and safety standards. Efficacy tests on Cerafusion technology. Recently, Heisen, Germany, an independent research institute certified by the German accreditation body, tested Cerafusion technology used in AS2 air surface sterilizer. The test performed by Hyson on the effectiveness of AS2 air surface sterilizer with the Cerafusion technology in deactivating airborne viruses shows that 99% reduction in airborne virus was achieved in 10 minutes. It also stated in the report that the result is comparable against envelope viruses such as coronaviruses and influenza viruses. An overview of the setup. The test room was done based on a 25 square meter room with a 75 cubic meter on an 80% RH and 20 degrees C. You can see the location of the AS2, the impinger and vacuum pump, and the nebulizer in the layout which the test was carried out. Prior to the application of the germ aerosol, the ozone generation was measured at 0.04 and 0.07 ppm for two different test measurements. The 5X174 virus was then introduced into the test room as a germ aerosol using the Typhoon fogger. The test duration was from 0 to 120 minutes. In the summary results, according to the Hyson, as can be seen from the table here, after 10 minutes, the maximum reduction factor was measured at 2.12 log reduction, which is equivalent to 99.19% reduction compared to the reference test. Other efficacy tests performed over the years. Monash University Sunway campus tested the Cerafusion technology on various bacteria, including mold. Nottingham University tested against various bacteria and fungus. From the scanning electron microscopy results, you can see the RNA and DNA of the fungus ruptured after subjecting to the Cerafusion technology. University Malaysia has also done various bacterial tests, but this specific test was done on a virus that caused hand, foot, and mouth disease. And you'll find that with the Cerafusion technology, there is no sign of virus activities as shown in the photo B. Last year, August 26, 2020, the Fujita University tested low level of ozone between 0.05 to 0.1 ppm against COVID-19 and proven to be effective to deactivate the virus. It also stated that the low-level ozone is harmless to humans. According to Dr. Paul Mitchell, director for the CDC, it says that ozone is very effective and at inactivating viruses, including COVID-19. In summary, the Cerafusion technology is proven as an effective solution. It has gained good traction and technology has been deployed internationally. Other than the Hyson study from Germany, the federal government of Germany has actually funded a study, an elaborate study using Cerafusion technology, which is still ongoing. We were told the preliminary result is very promising and we look forward to the final outcome very soon. Low-level ozone concentration between 0.05 to 0.1 ppm is effective to deactivate viruses and other pathogens, as we can see from the different studies. Ozone between 0.05 ppm and 0.1 is safe for humans, and it can operate as a standalone or complement with existing systems. This concludes my first presentation, and I will now move on to the second topic on air surface sterilization technology, creating a safer indoor environment. This is what I'll be covering in the presentation. Current challenges. We have heard from Dr. Chandrasekhar some of the challenges that we face, and I'll be sharing some of these which could overlap with what he had shared as well. I will do a quick overview of the challenges faced for IAQ and ventilation system in the current situation. This is not just for Malaysia, but a global issue as we engage with different stakeholders in different organizations internationally. The current pandemic has changed the world drastically, and IAQs has become an important and necessary consideration for everyone to maintain good health and safer living spaces for now and the future. There is an ongoing search for finding effective solutions to address pathogens spreading through droplets and aerosol, as we have heard earlier as well. According to WHO, the respiratory infection can be transmitted through droplets and aerosol. There is also the possibility of airborne infection transmission through ventilation system, and the time required to remove airborne pathogens from indoor environment. There has been a lot of discussion, even as we have heard earlier, as to whether the spread of the virus is through droplets or is airborne. We cannot ignore that both are part of the problem. The modes of transmission of infectious diseases can be spread through airborne droplets and on contaminated surfaces, as shown from this illustration as well from the earlier presentation. According to published research, COVID-19 in an aerosol form can last up to 3 hours, and on different types of surfaces, the virus can live longer. 72 hours on plastic, stainless steel 48 hours, copper 4 hours, and cardboard 24 hours. Another study has also shown that the other coronavirus can last up to 9 days on certain types of material. So we need to be careful and continue to practice good hygiene, as coronavirus or COVID-19 or the variants are not just airborne, but can also be present on surfaces. A study from a team of researchers from Pacific Northwest National Library Laboratory in the US reported that in a multi-room building, rapid air exchanges can spread coronavirus particles rapidly from the source room into other rooms at high concentration. When the infected person in the office to the left cough, respiratory droplets containing viral particles exit the office fan in the ceiling. Some of the droplets exit the building, while some are sent back into the building and into multiple rooms through the air handling unit. This research team found that a high ventilation rate can actually increase viral particles level downstream of a source room. There are other studies that reported similar situation, especially if the air distribution is not properly designed. ASHRAE, as we all know, has come up with many international guidelines, make it very clear that in its position document on infectious aerosol, that HVAC system cannot control all airflows and completely prevent dissemination of an infectious aerosol or disease transmission by droplets and aerosol. Therefore, we cannot solely rely on air movement alone to reduce the risk of virus spread, but we should approach the solution from a total ecosystem perspective in addressing air and surface contamination for any air indoor environment to be effective and results in better protection. This is a study on air changes per hour and time required for removal of airborne contaminants in a healthcare facility. This is taken from Minnesota Department of Health. According to CDC guidelines for environmental infection control in healthcare facility, typical frequency cited ACH for patient care areas are 6, 10, 12, and 15 air changes per hour. An example of 12 ACH would take 23 minutes to achieve 99% efficiency to remove airborne contaminants. This study was done based on an ideal condition where there is no additional virus being introduced into the room. With the latest finding from Heisen, Germany report on efficacy of Cerafusion technology to reduce 99% airborne pathogens within 10 minutes. And the data on ACH and time required for the removal of airborne contaminants. Cerafusion technology can improve the reduction of airborne contaminants with existing HVAC system. Therefore, it may not necessary to upgrade an existing HVAC system as a consideration as well. In this example, to increase the reduction rate of airborne contaminants using HVAC system, it will require much faster ACH. However, it could be very costly and probably not practical as well. Current recommendation, as we have heard earlier, and I will just do a quick summary. The current focus is very much on improving HVAC system or non-HVAC system. In the indoor space or commercial buildings with HVAC system, the recommendation is to improve the air filtration system or using additional air cleaners such as HEPA filters, UVC, ESP, or other ionization technology. In the non-HVAC system, the recommendation is to frequently disinfect touch surfaces or use portable air purifiers with HEPA filters or ESC or UVC. However, these current practices and recommendations have their own challenges. It is not necessary that all airflow is well distributed and air exchange in an indoor environment, especially in a commercial building. At times, we can experience certain locations where the air is stagnant or even not well distributed or even having an uneven airflow circulation. And we have also heard earlier from Dr. Chandra regarding some of the different air distribution flows. Constraints affecting existing HVAC system. While it is known by a lot of our customers or stakeholders that the ideal situation is to be able to upgrade HVAC system. However, in the practicality, there's a lot of challenges. For example, when you would upgrade an existing filter to a higher grade filter, such as HEPA filter, this will also likely affect the blower capacity and other related parts that may need to change as well. If it's an older building, this could be even more difficult or not possible at all. And the cost of upgrading will also be another major factor. HVAC system and non-HVAC system do not operate 24-hour basis. They do not address surface contaminants, and to get 99% efficiency to remove airborne contaminants reduction requires high air exchange rate or longer time period. How can air surface sterilization help? Follow up from my first presentation, Cerafusion technology is an effective sterilization technology that we can consider as it addresses the source of pathogens in an indoor environment using low-level ozone to deactivate the pathogens. As Dr. Chandra also mentioned, if we are able to eliminate the source of the problem, it will be very effective. And that's what low-level ozone in the presence in the environment will help to speed up the reduction of such pathogens. And it is always on a 24/7 continuously. So the indoor space is always being sterilized in air as well as on surfaces. The sterilization technology is also very scalable. We have done a size of 20 square meter up to 30,000 square meter space. The Cerafusion technology is also scientifically proven and complies to international standards. So as we have heard earlier, there is no one solution that can fix all problems, especially what we are currently going through today. This ongoing pandemic requires us to embrace new method or technology to enhance existing systems in place. We need a total solution approach rather than solely depend on HVAC or non-HVAC system to address the current challenges. The Cerafusion technology is an efficient technology to add on to an existing solution to provide added safety and protection on a 24/7 continuously where the existing solutions are not able to provide. The Cerafusion technology is implemented in many places internationally. In Malaysia, for example, many parts of the Resort World Genting facilities and in Jaya Grocers, all their 37 outlets nationwide have deployed the technology. In Germany itself, few cinemas have already started to implement the Cerafusion technology. And in Singapore, for example, Changi Airport, Terminal 1, Terminal 2, Terminal 3, and Terminal 4 are already using Cerafusion technology to combat COVID-19. The Changi Airport has conducted stringent testing and they have collected their own data before they roll out the Cerafusion technology. For the purpose of this webinar, I will share two case studies that were done recently. Case study 1 is done in NUS Music Room. The room size is 400 square feet. Room setting, no air conditioning with 85% RH, 23 degrees C. The product used was the AS30P. Ozone level is set at 0.04 to 0.05 ppm at ambient level. The objective is to determine the reduction of pathogen in a room by conducting surface swab tests after using the Cerafusion technology. They measure the reduction of total aerobic plate count and total yeast mold count 1 hour after using the technology. The test was performed by ALS. ALS is a leading testing, inspection, certification, and verification company headquartered in Brisbane, Australia. They have present in 65 countries, including Singapore. The location point for swab tests, as you can see, is on the keyboard, speaker, shelf, and speaker handle. Results after 1 year is shown here with the reduction of total aerobic count and mold yeast count. A reduction from 84% to 100% reduction. TLTC means too low to count, so there was not measurement done in this area. Similar test was done in Holiday Inn Orchard City Centre. This hotel is used as a quarantine center in Singapore. The room size is 350 square feet. The room setting, the FCU is set at high level with a 65% RH, 25 degrees C, and the product used is AS180. The ozone level at ambient is also between 0.04 to 0.05 ppm. In this case, ALS was also engaged to perform the swab test. Location of the point, as you can see, in 5 different locations. And the ozone measurement was also done. You will note that the ozone concentration at the outlet of the unit is 0.1 ppm. At 1.5 meter away from the device, set at maximum mode, is 0.05 ppm. And at the low mode, at 1.5 ppm, the ozone concentration is 0.04 ppm. The test data was collected after 45 minutes, and the results of the reduction can be seen here. In this case, the range was from 62% to 100%. So, in summary, to create a safer indoor environment, a more comprehensive approach is needed to address IAQ and ventilation in the new norm. We cannot solely depend on a specific solution, such as what we have mentioned earlier, whether it's a HVAC or non-HVAC system, even though it is necessary and important component as a solution. We need to embrace new technologies such as air surface sterilization to enhance the existing solution. And the importance of sterilizing air and surfaces 24/7 continuously. And lastly, the importance of added safety and protection to reduce the risk in the new norm and beyond. Thank you very much. And if you need further information, you can contact me at daniellu@medklinn.com. Thank you.
Thank you, Mr. Daniel Lu.